In this video, we're going to look at what happens when you have intersecting tangents. Remember, a tangent is any line that just touches the edge of a circle. And we've already seen in a previous video that the angle between a tangent and a radius is 90 degrees. What we're going to look at in this video is what happens if we have two tangents that just touch a circle and they cross. The only time they won't cross is if they are on exact opposite sides of the circle, and then they will be parallel. So most of the time they will cross. And what we know about these is that the distance between where this one touches and this one touches, so the distance between that point there and where they intersect, and between that point there and where they intersect, is the same. So that length is the same as that length. Doesn't matter where our tangents are, how close they are together or how far away they are. We know that the length between where they touch the circle and where they intersect are the same for both. Moreover, what we get is if we do draw in the radii, the two radius there, then we know that this angle here is 90 degrees because it's a tangent. This angle here is 90 degrees. We also know that the two radii have the same length because they're both radiuses. And if we were to join that point at the centre up to the point of intersection, then both triangles share that length. So we have two right-angled triangles where all three lengths are the same. So we have two congruent right-angled triangles. Sometimes we have to use that fact. So for any two intersecting tangents, the length between the points where they touch the circle and the point of intersection for the two of them is the same. And remember, if we also draw in the radii, we get two congruent right-angled triangles out of this. So let's look at two questions. In this question we have two tangents that intersect. The angle at the intersection is 70 degrees. Well, what we know is that this length is the same as this length. That's what our theorem says. So we have an isosceles triangle. So we know that A equals B, and we also know that A plus B plus 70 is 180. So A plus B is equal to 110. But if A equals B, then A equals B equals a half of 110, which is 55 degrees, because they have to be the same. So we have an isosceles triangle there. That's what we get most of the time. We get an isosceles triangle. So the two base angles here and here are the same. In this example, we're told that the whole angle where they intersect is 82, and we're asked to find that angle in the middle there. If we were to draw in the other radii here, we know that we would get two congruent right-angled triangles. So what that means is that this angle here is x, but more importantly, it means that this angle here, we can split it in half, and that one is 41. And this one over here is also 41. Because they're congruent triangles, the angles must be the same. Now we know we have 90 degrees up here, so we have 90 degrees and 41, so we have the remainder, x is equal to 49 degrees, so that the angles in that small triangle add up to 180. So that's how we use intersecting tangents. It's slightly different to the other circle theorems in that it doesn't relate angles, it relates two lengths that are the same, which normally gives us an isosceles triangle, which helps us find angles within the circle.